Welcome to lecture number 5. Machine learning locally weighted regression is the topic. Previously we were discussing about various features. Now here phi naught phi 1 x1 is sometimes we have phi naught plus phi 1 x plus phi 2 x square if the quadratic function is there, sometimes with square root x, sometimes with log of x, sometimes with x square, and so on. These are the different equations. Now we consider here that is the case. So feature selection algorithm, some of the characteristics we will discuss. It's feature selection algorithm for automatically deciding x squared as feature or square root of x. This is the common algorithm or common case we discuss. Now deciding, sometimes it is deciding some difficult. These are some of the features. This is the line which we obtain. So we use log as locally weighted regression in usually the case, and parametric learning algorithm and non-parametric learning algorithm. These are the two deviants of these algorithm. So according to this 1 and 2, some of details is given below. For the parametric learning algorithm, fixed set of parameters as phi I or theta I. It may be phi or theta. Somewhere it is theta, somewhere it is phi. But for number 2, non-parametric learning algorithm, locally weighted regression is non-parametric learning algorithm. Also, for the non-parametric, amount of data or parameters need to grow linearly with the size of data for the non-parametric learning algorithm. Now here 1 and 2 I have mentioned. So 1 is for 1 and 2 is for 2. In parametric learning algorithm, no matter how big your training set is, you feed the parameters. Then you could erase a training set from computer memory and make prediction just using the parameters phi I. So in parametric learning algorithm, training set doesn't matter. In non-parametric learning algorithm, the amount of stuff you need to keep around in computer memory grows linearly as function of training set size. So you need that data in memory till the end of your work. So non-parametric learning algorithm is not good when there is massive data set, as you need to keep all the data to make predictions. So non-parametric learning algorithm is preferred where there is not massive data set. So if there is massive data set, so then you have to keep the parametric learning algorithm. So here, if we want to predict this point, so these are different weights. So that line, if we take it LR as linear regression for it, and that it will be we make some slope line, called it as linear weighted regression. So to evaluate at certain x, that is the function is carried from the previous lecture. So if you want to get details on it, you have to observe and watch all the videos of the previous lectures. So that is LR linear regression. For linear regression, fit phi to minimize cost function and return phi x. T here is T for transpose, phi tx, T for transpose. Also LWR locally weighted regression. Nearby or neighboring points are in focus. So locally weighted regression, nearby or neighboring points are in focus to get the final function. So linearly weighted regression fits phi to minimize modified cost function. So that is the modified cost function I is equal to 1 to n with wi, that is the weight, with yi and so on, where wi is a weighty function. We have introduced it. So weighty function wi is equal to exponent minus with xi minus x whole square by 2. If xi minus x is small, then wi is approximately, or weighty function is approximately equal to 1. If that amount is large, then wi is approximately equal to 0. These are the two important conclusions here we get from today's topic. So that is the end of today's lecture. Thank you.